Hello everyone, I'm Larissa from Hikvision Headquarter Trainer Team. Welcome back to our CGSP CCTV courses. Today, we will together learn about the principles and applications of artificial intelligence. We hope through today's course, you can have a common knowledge of artificial intelligence. Let's take a quick look of training objectives. After our course, we hope you can understand the development definition and technical architecture of artificial intelligence, and understand that deep learning is the key to the development of artificial intelligence. Except that we want you can understand the definition and basic framework of deep learning, the process of deep learning, extracting features, and understand the three elements of deep learning. Well, here is our course content. We will talk about artificial intelligence overview first, and then we will introduce the definition and principles of deep learning and the applications as well. Okay, let's start with the artificial intelligence overview. It took nearly 100,000 years for human development to evolve from hunting to agriculture, and nearly 10,000 years for the Industrial Revolution to break out. But it was only 100 years before the industrial age fell short of the information age. From this, we can predict that relying on the exponential speed of development of technology, the human race will soon lead to a smarter and more diverse future world. In the historical development, it has experienced four technological revolutions. First Industrial Revolution, mechanization. Second Industrial Revolution, electrification. The third revolution, informatization. And the fourth revolution, intelligence. Artificial intelligence is the power of the new age. So now, maybe some of you have questioned, what is artificial intelligence? AI is a system that thinks like a human, such as decision-making, problem-solving, and learning. AI is a system that acts like a human. It is a study of how to make computers do things that only humans can do at the stage. It's the art of creating machines to perform functions that require human intelligence. AI is a system that thinks rationally. It is a study of mental abilities through the use of computational models. AI is a system that acts rationally. It is about the intelligent perception, reasoning, learning, communication, and behavior in complex environments. So next, we will give some examples to help you understand artificial intelligence concept. Speaking of AI, I have to mention the Turing test. What is a Turing test? If the computer can answer a series of questions posed by a human tester within 5 minutes, and if more than 30% of the tester mistakenly believes that it was answered by a human, the computer will pass the test. In 2014, the chat program Eugene Guzman passed the Turing test for the first time. According to the white paper on innovative application of artificial intelligence in China, artificial intelligence is a general term for the science of using computers to simulate human intelligent behavior. It covers the field of training computers to enable them to complete autonomous learning, judgment, decision-making, and other human behaviors. Speaking of scope of AI, it includes computer vision, natural language understanding and communication, cognition and reasoning, robot, games and ethics, machine learning. Now let's take a look at the history of artificial intelligence. Before 1956 is a gestation period when the computing machines and neural network prototype appeared. In 1956, artificial intelligence was born. From 1956 to 1974 is the first boom of AI development. Sensor, search-based reasoning, and the chat robot have been appeared. But soon, the development of AI faced the first underestimation. Many people thought that AI was just a toy, and the computing ability and complexity of computers were also questioned. Till 1987, with the advent of fifth-generation machines, knowledge engineering, and BP neural networks, AI has once again ushered in vigorous development. But soon, because of it failed to meet expectations, the capital invested in AI development was cut sharply. Until 2006, the emergence of deep learning algorithm has been promoting the rapid development of AI technology. In the past 10 years, the computing power of AI technology has improved and its application pages have become more and more extensive. After knowing the development history of AI, we should also know that there are 3 stages in history of AI development. First stage is weak AI, which is good at single task, also known as dedicated artificial intelligence. Second stage is strong AI, which can compete with people in all aspects, also be known as general AI. The third stage is super AI, which is smarter than the smartest human in almost every field. We can compare the ability difference between the dedicated AI and the general AI as the table shown below. The general AI has more abilities, such as ability of knowledge and skills transfer, cross-field reasoning ability, cognition, and mastery common sense, mastery of abstract ability. Okay, as you can see here, we give an architecture we show in the infrastructure and application of AI in an all-round way from different dimensions and layers. For example, from industry chain dimension, on the base layer, it is data platform, calculate ability, sensing system. On the algorithm layer, there are general algorithm, technology platform, and frame system. On the application layer are consumer terminal and industrial solutions. We can also interpret artificial intelligence systems from a technical dimension. On the base layer are data platform, processor or chip, and so on. On the algorithm layer are transfer learning algorithm, reinforcement learning algorithm, and on the application layer will be like smart camera, smart speaker, smart robot, and so on. From the service industry dimension, AI will be widely used in smart medical, smart vehicle, smart education, and so on. Well, I think you have already had a common recognition of artificial intelligence, have known what AI is, how AI developed, what kinds of ability it has. Now, we will learn more about deep learning algorithms, which belong to artificial intelligence. Okay, I think from this diagram, we can clearly understand the relationship between AI, machine learning algorithm, and deep learning algorithm. Deep learning is a subfield of machine learning. Deep learning imitates the way the human brain analyzes and processes information and uses complex nonlinear transformations to learn the representation of distributed and hierarchical features. Deep learning can better express data by continuously combining and abstracting low-level features to form high-level features with semantics. Let's take a look at general framework of machine learning algorithm. We give a model to machine with mapping collection and provide training data so that the machine learning algorithm start to training and get the best mapping. The X represents the mapping input and can be a voice. Y represents the mapping output. It will be like text, "Hello everyone." Through the machine learning algorithm, the mapping input can be transferred into mapping output, just like we say "Hello everyone," and it is automatically transferred into text, "Hello everyone." Both deep learning and traditional machine learning work with this framework. So what is the difference in the model of deep learning algorithm? Let's have a look. Deep learning is usually based on deep neural network algorithm. We give the deep learning algorithm model photo of goldfish. The deep neural network algorithm will recognize it and give the output, goldfish. We can also call the training mode like end-to-end training. What each function should do is learned automatically. The working principle of deep learning algorithm is similar to the process of information processing in the human brain. The process of information processing and learning will go through multiple layers, and finally, the best result will be obtained. The multiple layers in human brains and the deep learning algorithm, we call it deep neural network. From the figure, we can see that in addition to the information input layer and output layer, there are many hidden layers in the deep neural network, which continuously cross-learn and process information and finally get the output information. So the deep neural network not only has depth but also has width. The most basic component in deep neural network is neuron. Here we can regard the deep learning algorithm as a sigmoid function. X means the input data. Every input data will have its weights, and the bias should be considered into the results of calculating as well. So the sigmoid function be like A equals sigma Wx plus B. In this function, A is the best result of deep learning training. Just like human brains, the deep neural network is a really complex system. It has full connection neural network, convolution neural network, recurrent neural network, long short-term memory network. And the neurons is a basic component. Neurons form all these neural networks. The simple neural network modules we mentioned above are combined to form complex neural network modules. Well, we have talked about the deep neural network. I think you have known about how deep learning algorithms work. So now let's talk about the main ability of deep learning is feature extraction. Deep learning algorithms can form high-level features with semantics through the continuous combination and abstraction of underlying features to better express data. We can compare deep learning algorithms with traditional algorithms. Traditional algorithms need artificial designed features to be trained and to learn. It's a kind of shallow learning. As for deep learning algorithm, it will do data pre-processing, then extra features and transform features, and finish predictive recognition and gather results. And just like we have talked that deep learning algorithm can form high-level features with semantics through the continuous combination and abstraction of underlying features to better express data, so it is kind of self-learning features. Google has done a lot of experiments to analyze the impact of data and computing power on deep learning. In Google's FaceNet paper, the performance analysis of face recognition algorithm is listed. From the experimental data, it can be seen that with the model calculation amount increasing and the increase in the amount of training data, the accuracy of model has skyrocketed. The increase of training samples from 1 million to 100 million increases the accuracy of the algorithm by 10 points, and the high precision algorithm can increase the technical amount of a face image reach 1G floats. It can be seen that in order to build a deep learning application system with excellent performance, we must first find abundant data portals and accumulate a large amount of training data. And second, we must be able to develop a system with powerful computing power. Here we also listed the evolution of model computation and classification accuracy of deep learning algorithms. Through the previous discussion and the above formula, we can find that the deep learning models is a very complex neural network. This network has very good expressive ability and generalization ability, fitting such a complex mapping function. But we need enough data facing such a complex network and large-scale training data. We need very strong high-performance parallel computing power to solve the above cost function and gradient. So let's make a conclusion. There are three important elements of deep learning. First is network architecture. Network architecture is the foundation of deep learning, and innovations in network architecture can improve algorithm performance. Second is data scale. Data scale and data quality determine the upper limit of algorithm performance to a certain extent. Third is computing ability. Powerful computing power facilitates rapid verification of deep learning algorithms. Well, we have talked many about the principle of deep learning. Now let's see what kinds of applications of deep learning we can see in our daily life. First application is in the field of speech recognition. In 2011 to 2012, Google, IBM, and Microsoft adopted deep learning for speech modeling. The recognition error rate is relatively reduced by about 10 to 30%, and the deep learning algorithm can be trained on many more speech datasets than before. Next application is speech synthesis. In 2016, Google's WaveNet made TTS almost indistinguishable from human voices. Deep learning algorithms are also widely used in image classification, object recognition, and scene classification. At the end of 2012, in response to the outside world's doubts about deep learning, Hayton proposed the AlexNet deep learning model and made a major breakthrough in the ImageNet classification computation, which made the performance almost stagnant at that time, and the absolute classification error rate dropped by 10%. Deep learning methods officially enter the field of computer vision. Automatic image annotation is an application of deep learning as well. From October to November 2014, Google, Stanford, UC Berkeley, Toronto, UCLA, Baidu, CMU, and Microsoft almost simultaneously proposed their own automatic image annotation algorithm. Two different domains, image and text, are unified into the same deep learning framework. The deep learning can recognize the figure below and add the annotation like the boy is using computer, the man is riding bicycle. Next one is graphic Q&A. In May 2015, based on deep learning, a graphic question answering algorithm was proposed. Computers understand text semantics, analyze scenes, and automatically answer image-related questions. Deep learning algorithms are also widely used in identification cancer cells from medical images, or it is widely used for object detection and recognition. In the field of assisted driving, we can also see the deep learning algorithm. The algorithm can recognize various signs, objects, environments on the road to assist driving. Deep learning algorithms are also used in the field of games. It can recognize the different actions or the objects in the game and make the game experience better and smarter. When it comes to the application of deep learning algorithm, we have to mention the man-machine Go battle. AlphaGo is an artificial intelligence computer with a built-in deep learning algorithm. Entering 30 million moves of a human Go master into AlphaGo, let it play 30 million games against himself. AlphaGo forms a global view in self-play, forms an evaluation network, and revises the choices of moves. Okay, that's all for our course about basic principles and applications of artificial intelligence. I hope that you have got a common understanding of the basic knowledge of artificial intelligence. Thank you for your listening. See you in the next time.